Good evening to everyone. I'm happy to be able to share our project's preliminary results with you. And starting with this presentation, I would like to mention the reason why, despite being a geologist, I choose to work on this multidisciplinary project. The reason is the beautiful synergy created by earth and archaeological sciences, and the potential they have on preserving and showcasing the cultural heritage of the different communities. And what really intrigues me is to work towards achieving a sustainable tourism plan built upon a meshwork of history, arts, rocks, and nature. These pictures are from a recent project regarding the placer gold in North Greece. And in case anyone is interested, I will offer more information. Regarding the synergy in Tinos and the Ras ancient quarry, we are going to combine geology with archaeometry, lichenometry, collaborating with my friends Vasiliki Anevlavi and Dr. Torsten Jakovic, respectively. Aim of this study is to define the unique geological imprint of Ras, and these are a few representative photographs from the ancient quarry. Here you can, on the top right, you can see the quarry facade. And on your left, you can see different levels during the quarrying of the Ras serpentinite. Colored and especially green color stones were and still are sought after, and there are two cases of ancient quarries in Greece: the Thessalian stone situated near Larsa, classified as ophiocalcite, and the Lapis Lakedaimonios situated in near Sparta, classified as a volcanic rock. The previously unknown ancient quarry of Ras consists of a green color stone classified as serpentinite, and it's a rock similar to the Thessalian one. Serpentinite is the result of hydrosalteration of maltol-derived rocks, which are called protoliths, and this procedure takes place under different geotectonic environments, under which primary minerals such as olivine and orthoparoxene are transformed into serpentine. And these are a few photomicrographs demonstrating this transition from a fresh, let's say, a rock on our left to the serpentinized rock on our right. On your left, you can see the rather small occurrence of Ras serpentinite, and with blue color, the open pits are specified along with their debris piles of orange color on the map on your left. On the map on the right, you can see the locations of Ras serpentinite. And let's see if I can, yes. Here is the Ras serpentinite quarry. And here you can see the contemporary quarries of the rock called ophiocalcite, which is this rock over here. This is basically serpentinite welded with white color calcite. And very important is that this is a natural way to capture carbon dioxide. And here you can see the view from the ancient quarry of Ras towards the contemporary quarries of the northwest Tinos. Even microscopically, one can notice the difference between the two green stones of Tinos. In the Ras case, a bright green network is developed within the dark green one. Our first job is to identify Ras unique petrographic traits, and here you can see an attempt to quantify its components, meaning the pale green veins and the dark mass. Later on, we identified the mineralogy of these samples, and we concluded that the bright green mineral is chrysotile and the dark green lizardite, minerals of the serpentine group family, but form under different conditions. This was possible through the XRD that also enabled us to calculate the exact size of serpentine needles. Moreover, via BET, we are able to determine the pore volume and the specific surface area of the rock. This is how two different serpentine varieties appear under a transmitted optical microscope. So basically, we have this area of the rock in a thin section, and here is a photomicrograph from the microscope. This is the chrysotile corresponding to the light green veins here, and this is lizardite corresponding to the dark green mass behind. With detailed petrographic study, we were able to identify a very rare mineral that could be used for future provenance analysis, represented by these fine, I hope you can see them, fine orange crystals here. We have also identified the chemistry of each mineral phase found within the Ras serpentinite via electron microprobe analysis, where we basically can also acquire backscatter electron images like the one on your right. Being interested in confining Ras serpentinite potential uses, we went ahead and tested its strength, which is classified as medium strength, whereas the ophical side, the other green stone from Tinos, is classified under high strength. And this also correlates with its volume usage throughout the time. This is a video demonstrating how we acquire our chemical data. In order to measure the trace and rare earth elements, we apply the laser ablation method, which yields quick and in situ results with minimum sample distraction. Archaeologists especially always try to protect as much material as possible, so this is a very useful method to apply. Based on the results, we have a very good understanding of the Ras protolith and the environments that it was formed, and consequently what type of serpentinite Ras is. Based on the SAMs, there are three main serpentinite categories with respect to the geotectonic settings that they were formed: the abyssal, the subducted, and the mantle wedge serpentinites. The data collection is really important in building a global database that could help future provenance analysis. And this is how our results correlate with previous research. And the Ras serpentinite is correlated with subducted serpentinites on both lithium and cesium versus ytterbium diagrams. However, one can notice a huge overlap with other occurrences. And this is the reason why it is important to not base our study only in one aspect, for example, only on geochemistry. To conclude, the Ras serpentinite differs significantly in terms of genesis, composition, and mineralization when compared to other greenstones in the Hellenic region. The main macro characteristic is the development of bright green chrysotile network within the lizardite mass. Traits such as serpentine size, porosity, special surface, strength have been specified along with index minerals. Most importantly, the geotectonic context of Ras and its protolith formation has been identified based on the chemistry of the rock. One method is not enough. Different point of views lead to the complete description of the rock. And the collection of all these special characteristics makes up its unique geological imprint. Thank you.